Step 7, describing segments. Now we want to look at the case where the dependent variable is a categorical variable, where we use the full segment membership vector as a dependent variable in our regression framework. And to fit such a model, we need multinomial logistic regression, where we assume that the dependent variable follows a multinomial distribution. Implemented is our multinomial logistic regressions in the package NNet, which is a recommended package, and we can call it fit the model using function multinom. And here's the formula interface. The dependent variable now is a categorical variable with more than 2 levels, and explanatory variables we use again age and moral obligation. And that's the output we obtain. Here is how was the object constructed, and the coefficients are now a matrix, where like each row corresponds to the coefficients we would obtain for a binary logistic regression, comparing segment 2 to segment 1. So segment 1 is omitted. That's the baseline category, where we set the regression coefficients to 0 for identifiability. More information on including the reliability of the estimates can be obtained using summary. But still, all of that information might seem rather overwhelming at first. So the question we might want to ask us first is, what happens if we drop age from the model? What happens if we drop obligation 2 from the model? Does the model fit decreases significantly, yes or no? And this kind of questions can be answered using function ANOVA again. So function ANOVA tests the full model versus the model without age using a likelihood ratio test, and we would reject a null hypothesis that the fit of these two models is equally good. And here we are comparing the full model versus the model without obligation 2. And also here we would reject a null hypothesis. So both have their value in predicting segment membership. To see how good does this work, how good are we in predicting, we could look at the predicted values themselves, and predict applied to this multinom object returns the predicted class for each of the observations, and then we can tabulate the observed versus the predicted classes and create a mosaic plot to see what does it look like. We want to have two plots on the same figure, so we're using PA, then we look at the predicted values and we create our mosaic plot. That's the observed versus the predicted. So we see what does the distribution of predicted classes look like for each of the observed classes. And fortunately for class 1, we see the most likely class to be predicted is class 1. We also see that class 4 is never predicted, not even for the observations from class 4, and that given I'm in class 6, the probability of predicting class 6 is highest. Alternatively, we can also look at the predicted probabilities. Then we need to use predict with type equals prob. So this will return a matrix, because for each observation we have now a vector of probabilities to be in any of the 6 segments. We can arrange this now in a data frame where we include the predicted probability, what was the observed class, and for which class, predicting which class did we obtain that probability. So that's the data frame, and here we are now just looking at the box plot for observations from segment 6. So in this parallel plot we see these are the classes for which the probabilities are obtained, and these are all from for observations which are from segment 6. So we see the distribution of probabilities for each of the classes, and preferable this should be way up here and all others should be very, very small. And we are also see that we are obviously quite good at distinguishing between segment 5 and segment 6 in for these observations. The last thing we might want to look at is the effect plots. Instead of looking at all of the coefficients individually, what we can look at is again the effect plots from package effects. And this would tell us now for a person with average obligation, how does the probability to be in any of the classes change with age. So we see, for example, for segment 6, age has quite a strong effect to increase the probability to be in this group, whereas, for example, for segment 1, segment membership doesn't seem to change with age. Similarly, also here for segment 1, also moral obligation doesn't seem to have a strong effect, whereas for segment 6, the higher the moral obligation score, the more likely respondents are from this segment.